Good morning. My name is Fabricio. I'm from Brazil. And I'm a data scientist working for a large American news organization. More specifically, I work for the R&D team of broadcast division. This division owns some important TV channels and 29 TV stations across the country, providing national news, local news, entertainment, weather, and so on. My task is to help the R&D team to design and implement the next generation recommending system for the company, especially for the mobile apps and websites. The real world application that I brought to share today is a specific recommendation use case for our websites. When some user opens the detail page for some content, article or video, we have just after the end of the content what we call the infinite scroll section, which contains recommended news embedded in the same page. But at this point, all users actually receive the same recommendations, which is curated by our editors. And our goal is to provide personalized recommendations using machine learning to hopefully increase the user's engagement. It's important to acknowledge that, of course, it's a teamwork. And my role in this project is to review the state of art in terms of news recommendation systems, design and implement in TensorFlow a kind of hybrid model, and help the engineers to implement the full pipeline on top of Google Cloud Platform. Hellos. We chose TensorFlow in Google Cloud Platform because the flexibility to reuse high-level operations to build customized model, but also the scalability for training and serving the training model using Cloud ML Engine, but mainly because the simple way to that TensorFlow serving manage the model's life cycle in production. Our agenda for today is that I'm going to show how we adapted the model-based collaborative filtering, we adapted this model-based collaborative filtering, adding content features to produce a kind of hybrid model. And we know that good recommendation is not about just seeking models with good accuracy. And in the news domain, we have additional challenges like we have a huge number of contents being produced every day, and the timely nature of most of them. I mean, should we recommend some content with more than 1 week old, for example? The right answer is depends. If it is a kind of homemade video with some incredible rescue, why not, right? But if you have a kind of political content or the cultural agenda of the last weekend, definitely not. So we can just use a regular collaborative filtering, and since we are really interested in recommend the new content, we need to solve the well-known recommendation problems, which is the cold start problem. So the best scenario for recommending system is when we have users and items with good ratings, history, but in our case is a page view history. But since our users are anonymous, actually, we don't have profile or preferences. So for us, new users just will not get personalized recommendations. We have this curated content. So our API just fall back to that. But for existing users, we choose to start with a kind of matrix factorization algorithm that scales well in memory and training time. Because it's important to understand that our goal is to produce a new model for each station 2 or 3 times per hour. So we're talking about 100 models deployed a day per station. So we adapted this latent factors matrix factorization to incorporate content-based features. So let's see this in more detail. First, our data acquisition. We have 2 main data sources. We have Google Analytics with page views history and time on page for each user, and the company CMS with content data In our case, it's title, body, video transcriptions, keywords, and those things. So our objective here, I mean, what we want to predict here is given a user ID and then a content ID, we want to predict how much time in seconds the user will spend in this content. And using that prediction, we can recommend the most interesting content to this user. All data we need is kept up to date on Google BigQuery. So we start our pipeline preparing and getting data from BigQuery, exporting to Google Cloud Storage to make them available to our training process that's running in a Kubernetes cluster on Google. One concern about our data is it's very sparse. This sparsity is a problem because we have this huge matrix of millions of users and a lot of thousands of contents. And the time and page that we have for this sparse is just few, so we have most of them just empty. This is an additional challenge for a collaborative filtering algorithm. Well, first of all, let's remember what's a matrix factorization, how we get this low rank matrix factorization work. So we have this matrix R to represent all possible pairs of users and items, and the values of our cells is the time on page predicted for these items. The factorization operation that produces the resultant prediction for some user I and item G is this product of latent factors, representation of both of them, okay? So we have these latent factors embeddings variables to be trained using a gradient descent algorithm. I don't plan to spend much time digging into the code here, but just to show how easy it is, this line in red is the TensorFlow factorization operation itself. You also can see that I add some users, items, and global biases because some users just spend more time than others and so on. You can see also the prediction function here. It just runs the factorization operation for a batch of users and items and returns the predicted time on page for them. The training operation is like that. We calculate the error, which is the difference between the time on page in the training set and the predictive value, and pass this cost function to the gradient descent algorithm to minimize it, adjusting the latent factors values for items and users. So this is one interesting flavor of collaborative filtering that scales well. The first implementation had good performance. We take about 50 minutes to run the full training pipeline. The prediction quality wasn't that good, but it's okay. The root mean square error of the time on page was 125 seconds. But as expected, we had a major issue here. The recommendations weren't showing good signs of personalization at all. We run qualitative tests using carefully chosen personas with very specific interests. And even for them, the recommendations were dominated by the recent most viewed content. So actually here starts our research. We need a kind of hybrid model, adding content and user features into the matrix factorization to implement a hybrid model. But user features, we don't have profiles. How you do that? We start with this, we have a lot of categorical information in the contents, but we chose to use the text content itself. I mean, the title, the body, the video transcriptions, and we choose to use natural language processing techniques to capture the semantics of these contents and extract our final content features from them. So we use this word-to-vec algorithm, which is a two-layer neural network that extract the word semantics from the linguistic context of the words and represent each word as a high-dimensional vector. Most of you probably know word-to-vec, but there is a famous example that illustrates his power. Is this analogy question, right? Man is to woman, as king is to. We know that the answer is queen, but the model can calculate the difference between man and woman vectors and add this difference to the king vector, and looking for the nearest word vector, surprisingly, the model returns the queen vector. So it's very powerful. But we don't want to recommend words, right? So we need another step to combine the vector words of the text into one unique vector represents the whole content, which is the doc2vec technique. In order to visualize the result of this doc2vec, we embed a bunch of news into 200 dimensions each, and use this TSV clustering to visualize and try to see if this capturing the semantic of the context, the text is working well. So here we have this visualization 3D, and the colors here represent the site subsections. So let's explain a little bit. We have this big magenta color, which is the national news subsection. It would be interesting to break them down into smaller pieces. Let's zoom in this cluster in this corner. I don't know if you can read this, but the headlines here is about North Korea, Russia, Syria, military stuff, okay? So great, it's working. We can see that clustering working with the semantic of the context, not just words, not just common words. Let's spin a little bit more. We have another cluster here. Now we have headlines about Yahoo, Facebook, YouTube, Twitter. Interesting, it's working, right? Let's see another cluster, the last one. We have here a cluster with many different colors, which are different site subsections. Why, right? So we have here health, national news, money together. Well, the headlines here shows problems with food and recalls, drug recalls, car recalls. So it seems to be about product problems and recalls. So great, it's working, right? So let's move on. But actually we are not ready because in a content-based model, we need to correlate somehow the content with the user interest, right? This is a problem for us. So since we don't have the user profile, we need somehow to embed them into the same high dimensional space of the contents. So we want to have these items and users embedded in this context to came back to matrix factorization operation intended. So our features engineer, we have another phase now. After doc2vec, we run a clustering algorithm and identify some clusters. We are working now with 40 clusters actually. In the sequence, we calculate the centroid of each cluster and calculate the similarity between items and each cluster centroid, and use this similarity as a item feature. So instead of using this 100 of meaningless doc2vec dimensions, we are working with 40 features, which is the similarity between the item and the centroid of each cluster. It's clear. I mean, so feature 1 is the similarity between the content and the centroid of cluster 1 and so on. So the intuitive idea here is that any content can combine different subjects. And finally, we can embed so users into the same space. We get the user's page views with time on page for each content and combine these embeddings for these contents into one vector for the user. So we have now the users also embedded in these 40 dimensions, which is the subjects of the clusters. But before going back to the matrix factorization, let's visualize the semi-contents again and in this 3D space. So now we have this more colorful visualization, right? Because color here actually is the predominant cluster of each content, and you have 40 clusters. So let's see this orange cluster here. Let's zoom in. We have, well, this is the product recall cluster, remember. They are coming from different site subsections and was in different colors in the previous visualization. So our strategy is working. We have the same colors here, and the WorldVec could capture and the clustering work well, grouping together these contents. Another way to visualize this 40-dimensional data is using parallel coordinates. Here, each line, again, is the content, the color is the cluster, but we have this 40-dimensional and the similarity of this content and the centroid of each cluster. I filter out just few clusters to better visualize them. The dimension 1 here represents similarity with cluster 1, of course, which is the cyan cluster, okay? We are talking about the cyan cluster. And we get the top 5 contents. So we could say that this is about employment, US economy, something like that. Let's take a look at another cluster. This cluster, it's Magenta 1. It's about, let's say, health tips, okay? But we can see that Magenta contents are frequently in the opposite direction of the cyan contents for almost of the dimensions here. So, I mean, it makes sense because health tips and US economy don't have too much in common in general, right? But we have a group of Magenta contents with high values for dimension 1, which is economy. Why? Let's check. Well, we have health plan costs rise, health products taxes, Obamacare replaced, cigarette sales drop. So yes, definitely is a kind of mix of health and economy. Our content-based features seems to be working well, okay? So we can go back to the matrix factorization. Well, just remember, the time on page for a user I and G is produced by the product between the latent factors representation of users and items in the previous model. And these latent factors are variables trained by a gradient descent algorithm to decrease the prediction error, okay? But this matrix factorization for all kinds of collaborative filtering are unable to use content-based correlations of different items in the prediction because you just see the page views or the ratings, whatever. But now adding these 40 content-based features for items and users, we can fill up this gap and solve the problems that I mentioned before. So now instead of having a variable matrix U and V as a mapping between latent factors and users and items, we also factorized U and V into the product between the 40-dimensional embeds of users and items and a new latent factors matrix A and B. So latent factors now are not training for each user or item, but for each content-based feature or cluster dimension in respect to the item contents and the user historical interests. The changes in TensorFlow code actually are very simple. We kept our bias and just replaced these user latent factors and item latent factors variable by this product of embeddings and the new variables. So our final results. Our training time increased a few minutes, but remains good enough. The time on page prediction error is now 20% lower, which is a very good improvement. But most importantly, the personalization aspect is now working very well. Our test with personas showed very good personalizations. So we are working now to have a public beta soon to see the results in terms of real users engagement and other KPIs. This is not the end of story, of course. We are working now with other problems, like the capability to the model make a distinction between long-term interests and short-term peaks. And because our short time here, I also omitted a lot of relevant details about how we deal with the timely problems of our content, for example, and many others. But I hope that it was useful for you, okay? So feel free to reach me online. You can just Google my name and send me a message from LinkedIn or wherever. Let's talk on a coffee break. Thank you very much.
Thank you, Fabricio. We have questions? Thanks for the talk. So you can certainly build general machine learning models using TensorFlow, but TensorFlow focus is really on deep learning. And I understand that you are not using any deep learning techniques. So why TensorFlow? How TensorFlow is helping you in this test?
Actually, it's a misconception. See TensorFlow as a deep learning specific platform. It's a lot more general. So we are using TensorFlow not because deep learning, but because the whole infrastructure and how easy it is to build customized models.
Questions?
Hello. Thank you for your presentation. I have some questions about how did you deal with the sparsity of your data? So let me just, if I understand it, you first pick up your data and turn it to the embedding of the words for reduce the dimensionality, and then again you turn it like for the matrix factorization, right? Is that correct?
Yeah. Yeah.
So the first thing that I found interesting, did you use the pre-trained word-to-vec model for the embedding, or did you train it on your specific domain?
We have a collaboration with Google team. We try to use the Google News pre-trained word2vec, but the public available is too old, from 2013, I guess. Mm-hmm. And we have the Trump name that changed a lot during the time, so we can't use a pre-trained model like that. And the results with training with using our own contents was pretty good, so it's okay. We are training every training section, we train again the word2vec.
Okay, and how did you decide the dimensionality of even the embedding and the latent factors of the matrix factorization?
It's empirically like trying to grid searching different parameters and find the best one.
More questions?
Hello. I'm Mikaro. I work now in Telefonica, but before Telefonica I was working in global.com in the recommendation team. So the problems that you faced, I faced as well 2 or 3 years ago or some. And in fact, we had also a hybrid recommendation mixing content and mixing user to user, for example, algorithms and so on. And in fact, this changes in domains as well. So in sports, a content-based model or more content-based model works well, works better than just user to user, because you have a team, you are getting news from your team. But on news, the freshness and the newsworthiness is more relevant, for example. And it's more temporarily affected by the recent news and big things. In fact, we had a model, there still is nowadays a mixing of algorithms and what does work in one model or not, and multiple experiments, multiple A/B experiments, and even graph techniques and not recommendation things, because we have an ontology that works and the journalists classify the news and so on. So my question is, how do you deal with this variability of performance, and if the algorithms of content-based models go back to the news classifying it, and if you build a more of a symbolic AI model after doing all these machine learning techniques that you use?
Yeah, we have different divisions in our company. I work with the digital products of the TV stations. And their data science, it's a new thing. So we are working in collaboration with the whole company. But right now we are trying a lot of proof of concepts for different kind of problems. So I pick up just one small cut of the problem here to share in more details, right? You have a lot of problems. I mean, we create models to try to classify contents as timely or time-sensitive content. Sometimes the editors don't classify weather as weather. So our recommender eventually will recommend weather. So we build a classifier to, okay, this is weather, not in the right classification. So we have a lot of problems. I can say that's just starting with this division. So we are in a very early stage of our research. So we don't have all this maturity complexity right now.
More questions?
From what I got from your presentation, you show news that are somewhat related to each other, like the economy and healthcare. Say you have a user that likes video games and hiking. How do you correlate two things that may have no correlation, but they are within the user's preference?
Yeah, yes, actually don't have the preference itself, right? But the users spend time on contents, and those contents are correlated to the clusters that we identify using this natural language processing techniques. So if users spend a lot of time with different categories, but these categories actually are correlated to many different, I mean, I'm reading something in the health subsection, but health, the content is in health subsection, but it's talk about other things like economy in my example here. So we correlate using this, the time on page that users spend on each content, and the similarity of this content and the centroid of each cluster. So using this, we can see what is the interest of this user.
Now the last question.
Hello, thanks for the presentation. I did a PhD in recommendation system. What you're doing is like quite nice, but I'm still thinking that you're like throwing like a lot of data, knowing that, I don't know, like maybe like the time of the day, like someone is like watching the page. I'm thinking that maybe like someone is watching like weather information like in the morning, or maybe like more economy in the afternoon. And usually like in this kind of problem, it's maybe better to go and have, I don't know, like something that is like tensor factorization. So you can incorporate like all this information in like one like factorization. And by experience, I know that it's usually will like better prediction that if you're just like trying to build like something that is way smaller. So I'm not sure if you thought about that. And not so long ago, there is also like a paper from Google called Shallow and Deep, I think, news recommendation, something like that. And like they're also like solving this problem of like sparsity and using like all this kind of information. And I know that like this model is like way better than like what is like on the market today. So I'm not sure if like you thought about like using that.
Yeah, we did a review of a lot of things, and but as I said, it's a new division, this R&D, so we are trying different things in small steps. And we have problems, of course, because, for example, this problem that I showed, the editors curated this recommendation, and they don't want to be replaced by a stupid machine, right? So we are given small steps, but you are right. We have a lot of specific problems that we need to approach differently. Yeah, and thanks for the suggestion.
Thank you very much, Fabricio. For further questions, please approach Fabricio during the coffee break.